we're going to pull off the graph. So definition, all right? These are called periodic functions because they repeat themselves, right? They're like wave functions. Okay. All right. So the period is how often it repeats itself. So how often the graph repeats. And when we look at the graphs, I'll talk about that in a sec. The amplitude is the, here's the actual definition, half the distance between the maximum and the minimum values. Okay. Basically, if you look at a graph, it's from the midline to the peak, or the midline to the trough, if you want. Okay. There's actual formula that you will get, but it's max minus min divided by 2. That is your amplitude. So looking at these graphs here, these are all periodic because they repeat themselves. And so for the first one, if I asked for the period, how often does it repeat itself? So you have a choice here. You can go the distance between peaks, so peak to peak. You can go trough to trough, or bottom to bottom, whatever you want to call it. Or you can go, I'll call it midpoint to midpoint. So what do those mean? Well, peak to peak is the distance between the peaks. So in this case, what's the distance between the peaks? 8. This one's at 10, this one's at 2, so it'd be 10 minus 2. Or you could do the bottoms, I call them troughs. Be 14 minus 6, which would be 8. Better get the same answer for the same graph. Or you could do midpoint to midpoint. The only trick with the midpoint one is if you use this as your starting point, so this would be the midline. It divides the graph in half. The graph is rising up, so you can't go to this point. You have to go to the next point where the graph is still rising, okay? Again, you can see that would be 8. 8 minus 0 should be 8. And it's which one of those you will use will depend on the graph. Usually people will just use peak to peak, because that's kind of the most intuitive, but sometimes it's easier to look at other points. Amplitude. Like I said, formula is the max minus the min divided by 2. So what's the max of this graph? 10. The minimum is? So it's going to be 20 over 2, which is 10. You could have just looked at this graph and figured that out because it's the height from there. But not all graphs have a nice 0-point midline, all right? Like the next one. If I ask, we'll do amplitude first. If I ask for the amplitude of this graph, I mean, you can figure out where the midline is, or we could just use our formula. What's the max of the graph? 6. What's the minimum? -2. 6 minus -2 is 8 over 2 is equal to 4. So the amplitude of that graph is 4. What's the period of that graph, of this graph? Anyone? 6. If you go peak to peak, it's 9 minus 3. Trough to trough, 6 minus 0, blah, blah. Okay. What about this last one? Period, amplitude. What's the period? It's 10. If you go from this point where it's going down to this point, that's 10 units. Amplitude? Right. 2. Max is 6. Min is 2. Divided by 2. It's 4 over 2, which is 2. All right. Is that okay? So amplitude and period. Amplitude is basically the height from the midline. Period is how often it cycles back and repeats itself. All right. Now the trig graphs. Can I move? All right. Sine. We're going to do the sine graph on the next page. So you will need your calculators. You're going to help me out here. Sine of 0. Punch that in your calculator. Please tell me what it is. 0. We're not going to do 30. Sine of 90. 1. Not doing that. We're not doing that. Sine of 180. Okay. Sine of 270. And sine of 360. 0. There we go. Okay. We're going to plot these on the grid. So x-axis has degrees. Y-axis has the value or the ratio of the sides. It has a max of 1. So at 0 degrees, we get 0. At 90 degrees, we get 1. At 180, we get 0. 270, we get negative 1. And 360, we get 0. And if you connect those points, even though they say do not join the points, we're going to cross that out with a smooth curve. You get the sine graph. Now, the reality is, this is a restricted domain. I can keep, this is sort of like, I've plotted all the points in one complete circle, right? 0 to 360. But I can keep going. I can keep going around again to 720 and then blah, 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 blah. And you just keep going. So that means the graph can keep going in both directions. So if 270 gave us negative 1 and 90 gave us positive 1, what do you think 450 gives us? What about 540? There you go. And if you go in the negative direction, oh, what's that? There we go. And it can just keep going. Never goes above 1 or less than negative 1, unless you do other things to it. Okay, but that's a basic sine graph right there. All you really need to know, and I will say you should know the sine graph and the cosine graph when we look at that, is to make a quick sketch like that and know that that's 0, that's 180, that's 360. And then you can fill it in. That's 90, and that's 270, and it's 1 and negative 1. But you're going to have them on your study guide, I'm assuming. So, all right. So let's fill in this bottom bit down here. Try to fit it in. Okay. The domain of a sine graph. Are there any domain restrictions? No, there's no square root and there's no 1 over x or anything like that. So that means it's XER all real numbers or negative infinity to positive infinity. What about the range? What's the max value? 1. What's the minimum value? So it just oscillates between 1 and negative 1. Or you could write negative 1 to 1, like that. Square brackets because it includes those numbers. Amplitude. What's the amplitude? 1. What's the period? This is important. What's the period of a sine graph? How often does it repeat? 360 degrees. Or if you want to write it in pi, 2 pi. Sine graph repeats every 360 degrees. Okay. X-intercepts, where are the x-intercepts? Just give me the first 3 from 0 to 360. What's the first one? 0, and then 180, and then 360. You need to remember those. And the y-intercept is 0. Okay? Sine graph, you need to know it. That's sine graph. Going once, going twice. Now we're going to do the cosine graph. So they've done it in rads for us. Thank you very much. All right, we're doing cos. And we're just going to do. So cos of 0. Put that in your calculator and tell me what you get. 1. Cos of 90, pi over 2. What do you get? 0. Cos of pi. Negative 1. 3 pi over 2, which is 270. And 2 pi should get 1. Okay. Again, we're going to join the points or plot these. So at 0, we get 1. Pi over 2, so that's pi. So pi over 2 will be here. We get 0. At pi, we get negative 1. At 3 pi over 2, we get 0. At 2 pi, we get 1. That is the cosine graph. Well, from 0 to 360. That is the part you should remember. Okay. From 0 to 360, you should know the x-intercepts. We're going to write them down, I think, on the next page. And the y-intercepts. But of course, it's periodic, so it cycles. So it actually looks like that if you extend it out. All right, we're going to have to write these here. So we'll do it over on the side. What is the domain of this graph? Are there any domain restrictions for cosine? No. So XER are all real numbers. Negative infinity to positive infinity. What is the range? -1 to +1. Amplitude, period. What's the amplitude? 1, period. How often does it repeat? What's the distance between the peaks? 2 pi or 360. X-intercepts. Just give me the first two from 0 to 360 or 0 to 2 pi. You can give it to me in degrees if you want. Ninety and 270. And the y-intercept is 1. All right. Sine and cosine are very similar. They're basically just shifted. You think about it. If we took this graph and we shifted it 90 degrees that way, or this way, you got a sine graph. Okay? Move it that way. So you need to know sine and cosine from 0 to 360. All right, good? I know we're just burning through this. All right, now you're going to go to page 557, please, because we have to do the tangent graph. All right, tan of 0, please. 0. We're not doing that. Tan of, oh, we should do 45, actually. Tan of 45, sorry. What's tan of 45? 1. 1, there we go. Tan of 90. Error, because it means undefined. All right. Tan of 135, please. Sorry. -1. And tan of 180, please. 0. Okay. So let's plot this. It's, at 0, you get 0. At 45, that's 180. There's 90. After that, guesstimate there is 1. You don't have to get this actually perfectly right. At 90 degrees, this one is important, so half of 180 is here. We get undefined. So what that actually means is it's an asymptote. It's a vertical asymptote at 90 degrees. So if this is 90, vertical asymptote. So the graph goes that. At 180, it's 0. And if you kept going at 270, you get another vertical asymptote. And since 135 is negative, graph comes like this. I'm just going to draw the whole thing, actually, because it goes on forever in both directions. We don't use the tan graph that much in this class. That's a tan graph. Kind of weird looking. All right. Let's do domain, range, asymptotes, x-intercept, y-intercept. Okay. What is the domain of this graph? I.e., what can x not be? Just do 0 to 360. Where are the undefined points? 90 and 270. So x cannot be 90 and 270. What is the range of this graph? Sorry? I can't hear you, sorry. There is none, because it goes on forever in both directions. So you'd say the range is all real numbers, negative infinity to positive infinity. Because those lines just fly up and down. The asymptotes. Basically, it's the domain restriction. So the asymptote of x is equal to 90 and 270. X-intercepts. The first three from 0 to 360 are at 0, 180, 360. Y-intercept occurs at 0, period. That's the other one I wanted. All right. What is the period? How often does this graph repeat? (180°). Okay. If you go from this point to that point, that's when it repeats. It's 180°. It's different than sine and cosine. Sine and cosine is 360. Tan is 180, and that is going to be important later on. And the amplitude, does it have an amplitude? Does it have a max and a min? So the amplitude is not applicable. Okay. All right. That's it for this lesson. You need to know sine and cosine. You need to know tan. We don't use tan that much, but you should have an idea of what it looks like. But sine and cosine we use all the time. Okay. Breaks at 10 after, isn't it? Some awkward.